this one here is a polyprotic acid, and so this is going to be your bonus, not this specific one, but being able to do a polyprotic. And so I'm going to work through the polyprotic acid. I'm actually going to use some old footage of me working through it, so I'm going to splice it into this. So you can either stop the video right now. I'm not going to ask any attendance questions on this polyprotic acid. Polyprotic means it has more than one hydrogen coming off. Actually, you may want to watch it because I think I might put one on Chem 101. So you might want to watch it. But for when it get to your test, I won't put one on your quiz. When you get one to your test, this will be a bonus. You'll have a polyprotic. It'll be either a diprotic, meaning it has two hydrogens coming off, or it might be a triprotic. That one would be fun. So you may want to watch the video because I'm thinking about putting one on Chem 101. But I know for sure the one on your test will be a bonus. So if the video seems to change, it's because I'm splicing in an old video.
Something called a polyprotic acid. Poly means many, protic means hydrogen. Polyprotic means it has more than one hydrogen to come off. So this could mean you could have a double rice or a triple rice. What I'm going to do on the video is a double rice, and I'm going to give a double rice on your quiz, and you'll have a double rice on your test, and then I'm going to give a triple rice for a bonus to see anyone that would want to take that challenge. A double rice meaning it has more than one hydrogen, for example, carbonic acid, H2CO3. There are two hydrogens, but they don't come off. One, they don't come off completely, and they don't come off both at the same time. They're not strong, so they come off one at a time. A triple rice would be like phosphoric acid. It has three hydrogens. So we're going to do the double. So we start out with our initial rice, and we're going to, it is carbonic acid. Draw the double arrow. Excuse me. And one hydrogen comes off at a time, so we're going to take one hydrogen off. When I do this, this does not have a charge right now, and when you take off a positive one, you end up getting this hydrogen carbonate or bicarbonate ion there. So now it has a negative one. We're going to start out with 0.0037 molar. This is 0, 0. This is going to be minus X. We're going to add X, add X. We get X, X. So it just looks like a normal pre-AP rice table. That's what it looks like. So then we're going to put the products over the reactants, so you end up getting X squared, or 0.0037 minus X. We're going to set that equal to something. If you'll notice, there's a Ka1 and a Ka2 because it has two hydrogens coming off. The Ka1 is for the first hydrogen. The Ka2 is for the second hydrogen. You can see that the number gets a lot smaller, meaning it's not real favorable for that second hydrogen to come off. It's not great favorable for the first hydrogen to come off. Now, as long as this is to the negative fifth or smaller, you can mark through your minus X here, and then you could cross multiply or send this over and take the square root. Or if you're just a solver fan, you can use a solver. So whichever you prefer, you need to find X. I do believe if you don't use solver, you get 3.99 times 10 to the negative fifth. Or if you decide you want to use solver, you get 3.97 times 10 to the negative fifth. Okay, so that is our concentration. So whichever number, that is your molarity, we can trace our X back up. Today in class, they wanted to use the solver. They kind of are solver fans, which is fine. So we use the 3.97. It really gets us the same answer in the end, so it really didn't matter one bit. Because this is to the negative fifth, so that's a really small number there. And if I take 0.0037 and I subtracted something to the negative fifth and I rounded back to 2 sig digs, it actually would round right back to that number. It's less than that 5% rule that we have talked about in class. All right, well, our problem is that there's more hydrogen to come off of this. So, and also it asks for the carbonate concentration. So that's not carbonate, that's bicarbonate or hydrogen carbonate. So I'm going to now start with this ion, that hydrogen carbonate, and do my second rise. So HCO3 minus 1. Now its hydrogen is going to come off. Not very well, but it's going to come off. Now, we usually put zeros under those, but if we go back up, I'm going to get this thing to move with me, there's some hydrogen here. So we've got a value here. So this is going to come down in our table, and this is going to be our initial for this guy. So we don't care about that guy because he's not in our new rise table. But this has a value. And like I say, we use this number in class, so I'm just going to work with that one. But you could do the 99. And nowhere up there did it mention the carbonate, so it's starting out at 0, which is good because if it starts out at 0, we know where we need to add the x to. So we're going to add the x here, we're going to add the x here, and we're going to subtract the x there. So we get 3.97 times 10 to the negative 5th minus x, and then 3.97 times 10 to the negative 5th plus x, and then we got 0 plus x. It's getting really pretty now. So down on the top we get 3.97 times 10 to the negative 5th plus x times x divided by 3.97 times 10 to the negative 5th minus x. And we're going to set this now equal to, whoops, where'd it go? Our Ka2, 5.6 times 10 to the negative 11th power. Well, a second ago, this was to the negative 7th, and I could mark through my minus x. This has now gotten a lot even smaller, so I can get rid of this minus x here. I can also get rid of this plus x. And now if you'll see the top and the bottom are the same, those are going to cancel, so our x magically equals our Ka2. Does that always happen? A good percentage of the time, depending on your K value. Now, if this had been like to the negative 3rd or something, no, it wouldn't happen. But I don't think on any of the polyproducts it's any number like that. All right, so now there's my second x. If I follow this up, it's asking for the carbonate, and carbonate is x. So this is the answer to my carbonate ion. To find the pH, well, I need the negative log of my H+. Well, I had them in class to check this. If you'll notice, 3.97 times 10 to the negative 5th, and we're going to add x to it, and x was 5.6 times 10 to the negative 11th. If I add this number and that number together, look at the power difference. It's essentially the same number, but I had them do that and take the negative log of it to find that pH. And then I had them just take the negative log of the original number. And what we found out with those two different numbers, using the bottom equation, we got an answer that looked like this. Using the top and not the plus x, this part, not the bottom right, we got an answer that looked like this. Whoops, there's a 4. And I may have those mixed up, which one's which. But I wanted to prove a point that essentially, because we're going out 2 decimals, all the pH, the true pH, is coming from, whoops, coming from the first hydrogen coming off. So most of the hydrogen ions are here, coming the first one. The second one barely comes off and barely gives us any hydrogen, affecting the pH just way out in the decimal, and it's not even lowering it hardly any at all. I mean, it's lowering it. That's definitely a lower number, but way on out. So a polyprotic, to find the pH, you definitely can just rice it once. But to get that second ion and to get full credit on your quiz, you're going to want to rice it second just to kind of prove it. So that's all we